Assalamualaikum and welcome back to our lecture. Next we're going to do exercise 1. For your information, the numbering for this we done in part 1 already. Hopefully you're going to refer it back how we managed to do those numbering for unknown and known displacement. Alright, for this case, on the beam, we're gonna have UDL, which is 12 kN per meter. Due to that UDL, there will be action due to that load. Take member 1, we're gonna have a UDL, which is W. The length is L, can be any length, we just name as L. Due to that load, we're gonna get an action at the end, and also we're gonna have moment. You learned this previously in theory of structure. For the vertical, refer back your theory of structure. WL divided by 2, that for vertical action, which is this one, and for moment on the action, the formula for that is WL squared over 12. That is action due to UDL on that stretch. Due to the action, we're gonna get a reaction. For the reaction, the same magnitude but different direction. So this is a reaction, same magnitude, WL over 2, and also the moment, same magnitude but different direction, WL squared divided by 12. Remember, the value we're going to put in your matrix, we're going to take on action. Now we're going to consider member 1. Due to UDL, and remember fixed and moment. Fixed and moment formula, you learned that in theory of structure previously. For member 1, you're gonna have vertical action, and the formula for that one is WL over 2, and the value for that one is 12. The length for that one is 5 meter divided by 2. So we have 30 on that side, and also we have action load 30 as well. And you have to calculate the action on the moment. The formula for that one is WL squared divided by 12. So 12, length is 5 meter divided by 12. So we have 25 on that direction and 25 on that direction. So always remember, to calculate this value, you need to use an action direction. So here is 25 for moment. And on member 2, there's no external force such as UDL or point load. If do have a point load, you have to calculate what is action due to that point load. To do that, you have to refer table for fixed and moment and refresh back what you had learned for fixed and moment in TOS previously. So in here, I just copy from textbook for the fixed end moment. For the case where you can see the point load not exactly at the center of your beam, this point load exactly on the center, and you have series of point load here, this one at same distance. How about if that P not at the same distance? This means you have to calculate one by one for each point load by using this formula. Now let's calculate what is K1 and K2 for member 1 and member 2. So this one is for K1, small k, we take out the EI, and don't forget the numbering for your member stiffness matrix. For member 1, always remember our near Y, near Z, for Y and for Z. So now we have to do numbering. For near Y, 6, 5. For member 1, 6, 5, 4, 2. 6, 5, 4, 2. Then you need to calculate value inside this matrix. 0.096, 0.096, negative 0.24, 0.8. Just do the half side, then the next one we just simply copy it. This one is 0.4, and this one is negative 0.24. This means you save your time. So we done for member 1. Next you need to do for member stiffness for K2. Take the EI out. 4, 2, 3, 1. 4, 2, 3, 1. Calculate value inside that matrix. 8, negative 0.96. This one is 1.6. Done half side, then simply copy it because it's symmetry. So we done for stiffness matrix K1 and K2. Then we have to combine it for our structure stiffness matrix, and don't forget the formula is QKD. Since we have two members, the size of our matrix is 6 times 6. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So you need to find what the value on each cell is enough for you to do half side. 1.6, 0.96, 0.8, this 0.24, 0.096. You've done half side for K, and then you just simply copy it. So this is your Q equal to, we take our EI out because it's constant, and we already determine our known and unknown, the known and the unknown. So the known is D1 and D2, and for D3, 4, 5 and 6 is known, which is 0. So 0, 0, 0, 0. So this is the line between known and unknown. Line between QK and Q unknown. So 1 2, so 1 2. So this is the line to split between unknown and known, and also to split between K11, K12, K21, K22. So now let's find what is value for QK. So Q1, Q2, refer back in here. It's for Q1, this one for Q2. The value for Q1 is 0. However, at Q2 here, we have 25. Same direction as rotational displacement 2. That means in here is 0, and for Q2 is 25. Then we need to find what is for Q3, 4, 5, and 6, which is this one is Q unknown. Let's check back for Q3. For Q3, no action, which is, that means it's no load on member 2 here. Q3. And for Q4, in here we have action due to UDL, which is 30. That means at Q4, we have to write as Q4 minus 30. Check again, because direction here going up, this one is going down. So Q4 minus 30. Go back to your matrix. For Q3, we write as a Q3, and for Q4 minus 30. Now let's check for Q5 and 6. Refer back here. At 5, here you have a moment here in different direction. That means Q5 minus 25, and for 6, this going up, this going down with magnitude of 30. So that means Q6 minus 30. Back to your main matrix. For Q5 minus 25, and for Q6 minus 30. So we assemble our QKD for our structure. Now we have to find what is value for D1, D2, Q3, Q4, Q5, Q6. Same as a previous step. You have to expand the matrix. You have few equation, then you have to solve it by using simultaneous equation, or you can use matrix reduction to solve your matrix and you get the answer. From the main matrix, we can split into two equations. For QK, we can find displacement. We're going to find displacement on that. So here is 1.6, 0.8, 0.8, 2.4. And for K12, we times by dk is 0. So we can cancel out easily because all the value is 0. So in here, I'm going to share to you to expand this matrix. So for first one, 0 equal to 1.6 times D1 plus 0.8 times d2 plus 0. So this is first equation. Then we're going to have second equation, 25. We take EI constant to other side. So we're going to have 0.8 d1 plus 2.4 d2. So second question. So we can solve it out and we can get our d1 and d2 value. So for d1 value is negative 6.25 divided EI, and for d2 is 12.5. It is up to you to use simultaneous equation to solve this problem, or you can use matrix reduction to find your d1 and d2. Now for the second equation, we're going to find Q unknown, which is forces or moment. So from the main matrix, K21 is negative 0.96, 0.96, 0, 0, negative 0.96, 0.72, 0.4, 0.24. And for our decay, d non is a 0. So here 0, 0, 0. That means we can cancel it out for this one because it's 0. So previously we know what is our value for d1 and d2. We need to expand this and we will get those forces or moment. Take for example for Q3, negative 0.96. Don't forget your EI value, negative 6.25 over EI minus 0.96 EI times 12.5 EI, and you get the answer for that one is negative 6 kilonewton. Do the same for Q4 and you will get Q4 is 33 kilonewton. Check back what is Q4 and Q3. In here, you know for Q4 and Q3 is force. So that's one certainly in kilonewton. However, for Q5 is moment. So unit for that is kilonewton meter. So let's do for Q5. Let's do for that. Try to do that. For Q5, Q5 minus 25, 0 plus 0.4 EI times 12.5 over EI, and then you will get Q5 is 30 unit, certainly kilonewton meter. And then for Q6, is 33 kilonewton. Now let's check if your answer is correct or not. You have your beam. Here is 2.5, 2.5, 2.5, 2.5. So let's make this way. 2.5 meter, 2.5 meter, 2.5 meter. So at node 3, you're gonna have downward of 6 kilonewton, Then at node 2, you're gonna have upward 33, and then node 1, you're gonna have upward 33 kilonewton, and also at 1 we have Q5, which is 30, and also from UDL on member 1, 12 times 5 is 60 at the center, downward due to UDL. So now let's check. We take summation moment at 1, which is this one is node 1, node 2, this one is node 3, refer back in the initial stage. S0, clockwise positive. So 60 times 2.5 minus 33 times by 5 plus 6 times 7.5 minus 30. This one equal to this equal to 0. And also we can check our summation of Fy equal to 0, positive upward. So 33 plus 33 minus 60 downward, then minus 60 equal to 0. This means our answer is correct. So we done for exercise 1. Alright, thank you very much. Assalamualaikum. Have a good day.